Alright, let's look at the properties of absolute values. Alright, so if you take the absolute value of the product, it's going to be the product of absolute values. And also, if you take the absolute value of the quotient, it's going to be the quotient of absolute values. Alright, let's prove the first one. And proof of the number 2 is the homework. So proof of number 1. Right. Let's start with the left hand side. And I'm going to use the exponential form. So I'm going to call it the R1 e to the I theta 1 times R2 e to the I theta 2. Right? Then if you combine that, you can see that we have R1 and R2 together. And multiplication of exponential function, we just add the exponent together. Right? Then you can see that this is going to be simply the absolute value shows up right here in front of the exponential function. So this is just going to be R1 and R2. Right, but this is going to be exactly the same thing as R1 is the absolute value of Z1 and R2 is absolute value of Z2, which is the right hand side. Right, so we could prove number 1, and number 2 is very similar to number 1. Right. Let's look at the benefit of, let's do a number 2, right? So if you have to, if you want to find the absolute value of 1 minus square root I over 1 plus I, what you need to do is you can just simply find the absolute value of the numerator and absolute value of the denominator separately, right? So an absolute value of numerator is square root of 1 squared plus negative square root of 3 squared, right? And the bottom is square root of 1 squared plus 1 squared. So this is going to be 1 plus 2, so square root of 4 over square root of 2, which is square root of 2, right? So we could easily find that. Let's say if we didn't have property number 2, then you would have to write it in the form of ax plus bi. So let's do it that way too, right? So this was pretty simple, and so here's the without property. So it's equal to. Alright, first thing I would do is we have to rewrite it into ax plus iy form, not the a plus ib bi form. We multiply top and bottom by a conjugate of the bottom guy. So you have a 1 minus I, and up here it's going to be 1 minus I, so that we don't change anything, right? So if you multiply out, you're going to get this, right? On the bottom, we have, so it's 1 plus minus I squared. 1 minus I squared would be negative 1, so it's going to be plus 1, right? Then multiply out, so it's a 1 times 1 is 1. 1 times negative I is negative I. Negative square root of 3i times 1 is negative square root of 3i. And a negative square root of 3i times negative I would be negative square root of 3. Right? Then we can just clean up a little bit. Right? So I'm going to take the real part, which is going to be, let's see, which are the real part. So we have 1 here and that. So it's going to be 1 minus square root of 3, and you still have divide by 2. Right, the imaginary part would be here and here, so there's a negative sign in both, so I'm gonna put minus. So it's going to be 1 plus square root of 3 over 2i. Right, then you would have to do a squared plus b squared. So in this case, actually square root of, right, this guy squared, which is going to be 2 squared would be 4, and 1 minus square root of 3 squared would be 1 minus 2 square root of 3 and plus 3. Right, and let's see, this guy's square would be negative sign, it's going to be positive, so 2 squared would be 4, and then 1 plus square root of 3 squared would be 1 plus 2 square root of 3 plus 3. Right, so we have that. Then you can see that we can cancel out negative 2 square root of 3 and positive square root of 3. Then you end up getting 1 plus 3, 4 over 4, plus 4 over 4, so square root of 2. Right? So you can see that answers matches up. But you can see that applying property number 2, it is very, very simple. All right? That's it. I hope that this was clear.